In this video, we will discuss about combination of resistors. We studied resistance, and resistance opposes the flow of current. Where? In the circuit. So, we are having, this is what? This is circuit. And what is the circuit? Circuit is closed path. In this circuit, we are having some elements. This is what? Voltage source. This is active elements. And R1, R2, R3. These are what? Passive elements. And they are what? Resistors. So, we are discussing about combination of resistance. Combination of resistance are two types. What? Combination of resistors are two types. First one is the series combination of the resistors, and second one is what? Parallel combination of the resistors. In this class, we will discuss about first one, series combination of a resistors. So, this is the series circuit for the resistors. In this circuit, this is circuit. What is this one? This is circuit. Why? Because it is the closed path. This is what? Closed path, in which R1, R2 and R3 are three resistors and they are connected in the series. Clear? R1, R2, R3, they are connected in the series, and V is what? Voltage source. V is what? Voltage source, and from the source current I is flowing. Current I is flowing from positive terminal of cell to negative terminal of cell. So current always flows from positive terminal of battery to negative terminal of battery. Clear? Now this current starts from this terminal, positive terminal. Now for the R1, there is the current what? Current I is coming till. Now this current I is entering to this resistance, then that entering point is what? Positive. Current I is leaving from this element, this resistor, so this leaving point will be what? Negative. Now this same current I is entering to, whatever current I entering and leaving, again this current I is entering there. So for this element R2, entering current is there, so this point for this element, this entering terminal will be positive. Now this current I is leaving from this element R2, so this will be negative. Now for this element R3, this current I is again entering to this element, so this will be positive and this will be what? Negative. So what you are observing? In the circuit, current starts from positive terminal of battery to negative terminal of battery. Whenever current enters to the any element, that entering point, this one, this one, this one, entering point is called positive terminal, and leaving point, this and this, leaving points are called what? Negative terminal. Now current I is entering, resistance value is R1, current I is entering, resistance value is R2, and current I is entering and resistance value is what? R3. In all elements, in all resistors, R1, R2, R3, current value is same. In all elements, same current is flowing. What current? I is flowing in this circuit. Same current. But resistance value is different. We studied what about the Ohm's law? Ohm's law is V equal to IR. Current value is same, but resistance value is different. 2 ohm, 3 ohm, 5 ohm. Like, if resistance values are different, but current is same, 2 ampere current is flowing. Once we multiply 2 into 2 ohm resistance, 4. 2 into 3 ohm resistance, 2 into 3, 6 volt. So voltage value will be going to be different. What? Current flowing in all elements, all resistance is what? Same, but resistance value will be the different. So dropage across for this element, what will be the potential difference? V, voltage. For this element, what will be the voltage? V1. Why? Because I into R1. It means dropage across this one, dropage across this one, dropage across this one. What is the dropage? Dropage is a voltage. Voltage across these elements, these resistors, this one, this one, this one will be the different. Why? Because R1, R2, R3 are the different. R1, R2, R3 resistance values are different. So obviously once we product current into resistor, then voltage values will be what? Different. So in the series combination, in a series circuit, current value will be the same but voltage value will be what? Different. In the series circuit, current values will be the same but voltage value will be different. But our task to find the what is the topic? Combination of resistors. We are having 3 resistors. How we will find its equivalent resistance? One resistance how we will find? So we want that formula. So in our syllabus we are having one law, Kirchhoff's law, and Kirchhoff's laws are what? 2 types, Kirchhoff's current law and Kirchhoff's voltage law. Kirchhoff's current law is applied for the node or junction, but Kirchhoff's voltage law is applied for the closed loop, closed path, or we can say closed circuit. So this one is the closed loop, so we can use Kirchhoff's voltage law to find the equivalent resistance. How? So from Kirchhoff's voltage law, first we should know what is the Kirchhoff's voltage law. What is the Kirchhoff's law? Kirchhoff's voltage law. 2 laws. Kirchhoff's voltage law is what? Algebraic sum of the voltage in a closed path. Algebraic sum of the voltage in the closed path will be 0. Observe. Voltage sum in a closed loop will be 0, will be what? Sum of voltage. What? Sum of voltage in a closed loop will be what? 0. This is the Kirchhoff's voltage law. So this source having voltage V, this element having voltage V1, this one is having V2 and this one is having V3. So how we will find the sum of the voltage? Once current is, this current flow of direction of current is what? This one. Once current is entering to negative terminal, then sign of voltage will be what? Positive. This I current is flowing in this circuit, and this current I is entering to negative terminal, leaving from the positive terminal, starts from the positive terminal but entering to the negative terminal. So entering is negative, it means voltage sign will be what? Positive. We will take positive sign. Are you getting what I am saying? Current is entering negative, it means voltage sign will be what? Positive. Now this current is entering to positive terminal, so sign of voltage will be what? Negative. V1 will be what? We will take negative. Now this current is entering to positive, so sign of voltage will be what? Negative. Current is entering to positive terminal, sign of voltage will be what? Negative. And finally sum of these voltage will be 0 is what? Kirchhoff's voltage law. So V minus V1 minus V2 minus V3 equal to 0. This is what? Kirchhoff's voltage law. Observe. Our task to find the equivalent resistance for the series resistor. So how we will find? We are having this circuit. This is the closed circuit, or closed circuit we will apply Kirchhoff's voltage law. And what is the Kirchhoff's voltage law? Sum of voltage will be equal to what? 0. And how we will find the sum of the voltage? When current enters to the positive terminal, sign of voltage will be, when current entering to, this current is entering to positive. Entering positive, it means sign of voltage will be what? Negative. We will take minus. We are taking minus. Now this current I is flowing and entering to negative in the source where it is entering to the negative terminal. This is negative, so we are taking positive and taking sum and equal to 0. Clear? This is Kirchhoff's voltage law. Now we are separating V equal to V1 plus V2 plus V3. This can be written as like this, no doubt. Another way we can say sum of voltage in a closed loop. What is the Kirchhoff? One is this, sum of the voltage equal to 0. How we will write? I explain. I hope you understand. But another way we can also write, once, how we will write the Kirchhoff's voltage law equation? Voltage rise must be equal to voltage drop. Voltage rise, one side we should take voltage rise. Voltage rise means increasing voltage. Rising means minus to plus. So only this source having current increasing, minus to plus, voltage is increasing. Now in which, how voltage rise must be voltage drop. Voltage rise must be drop, in which voltage is rising, minus to plus will be one side and plus to minus will be other side. So V1 is minus to plus, but this voltage is what? Plus to minus, plus to minus, plus to minus. So these will be where? On the other side. This is also a Kirchhoff's voltage law. Clear? So observe again what we are doing. We are applying Kirchhoff's voltage law. What is a Kirchhoff's voltage law? Sum of voltage will be 0. When current entering to negative, voltage sign will be positive. Entering to positive, then voltage sign will be what? Negative. Solve, we are getting this one. Or another way we can say voltage rising must be equal to voltage drop. Voltage rising means minus to plus voltage in one side and plus to minus voltage. This is the plus to minus. Current is entering. Direction, how we will take? From the direction of the current. In which current is entering means plus to minus, plus to minus, plus to minus. In which current is entering where? Minus to plus. It means this voltage is rising voltage. This will be what? Decreasing voltage. So voltage rise must be equal to voltage drop. So we are getting this equation. We studied in the 10th standard, but we are having Kirchhoff's law, so we should know how we are getting series combination of the resistors and parallel combination of resistors by using Kirchhoff's voltage law. This thing is very important. Why? Because this standard having Kirchhoff's law, so we should be use this one. So now we are getting this equation. We know that what Ohm's law we know, V equal to what? IR. Dropage across this any element, dropage across and voltage dropage across any element will be directly proportional to current flow into the element. So V equal to IR is what? Ohm's law. Now for the R1, R2, R3 resistors, what will be the voltage? V1 equal to IR1, V2 equal to IR2, V3 equal to IR3. We will put these values in equation number 1. Then what we are getting? Putting the values of V, V1, V2 and V3 in equation number 1. This one. We are putting and solving. Now I is common in all three. So we will cancel I to I. What will be remaining? R equal to R1 plus R2 plus R3. R is what? Equivalent resistance. Once three resistors are connected in the series, then sum of these resistance will be the equivalent resistance. If this is 2 ohm, this is 2 ohm, this is 2 ohm. Now equivalent resistance will be what? These three will be converted into the single resistance. How? 2 plus 2 plus 2, 6 ohm resistance. Clear? So on the place of these resistors we can use, this is 2, this is 2, this is 2 ohm. But place of these resistance we can use single resistance, that is what? 6 ohm resistance. Clear? So once three resistors are connected in the series, then equivalent resistance will be sum of these all resistance. Clear? R equal to what? Equivalent resistance. Now if n resistors are connected in the series, then how we will find the equivalent resistance? Simple. If 5 resistors are in the series, sum of all 5 resistance value, this will be what? Equivalent resistance. If 10 resistors are connected in the series, then sum of these all 10 resistors values, and that will be what? Equivalent resistance. So R equal to what? R1 plus R2 plus R3 plus R4 plus R5 and so on. All resistance sum will be what? Equivalent resistance, and this is what? Combination of the series resistors. It means finally we can say combination of the series resistor is what? In the circuit, once n resistance, 2 resistance, 3 resistance, 5 resistance, they are connected in the series. Series means what? Current flow is the series. When we will decide the series, these are in the series. Why? Because in these all elements current is same. Current is value is the same, but voltage value will be different. Why? Because we are having different resistance values. Once resistance value different, current is same, then voltage value will be changed. Why? Because V equal to IR. I is same, no problem, but resistance value same, resultant value will be the changed. So in the series, why they are there in the series? Because current value, current flowing in these all elements is what? Same. Clear? So this is what? Series. In the series circuit, equivalent resistance of 3 resistors, and for the N resistors are connected in the series, and this will be what? Equivalent resistance. I am having one example there. 2 resistors, 2 ohm and 2 ohm, both are having 2 ohm and 2 ohm values. Then some equivalent resistance of these two will be this one. 2 plus 2 will be 4 ohm. Clear? Once we are having 2 and 3 ohm, then what will be the equivalent resistance? 2 plus 3. 3 plus 2 will be what? 5 ohm resistance. So like this we can find this equivalent resistance of the series resistors. Equivalent resistance of a series resistors. If nth resistance are connected in the series, we will add all the resistance. 5, then we will add 5. 10, then we will add all 10 resistance. That is way to finding of the equivalent resistance of a series resistor. Clear? So that's all about this topic. Thank you so much.